Find the width of the V-slot shown. So suppose you have, I'm looking at this and I feel like this is a groove that's been bored, or a cross-section of a groove that's been created in a board. You have this board and you have this groove that's going in it. It's a V-shaped groove. That's kind of what I see when I look at this. And so that's how that's how I think this should be interpreted. If we want this particular slot to have a depth of 5.500 centimeters, and we know from the manufacturer that this is 62 degrees and 20 minutes, the angle, this angle right here, is 62 degrees and 20 minutes. We're trying to figure out what the width of this groove would end up being, that ends up being cut here. So I'm envisioning this is like a router bit or something like that that has a particular angle from the manufacturer. We're trying to figure out what the width is going to be here. So if you draw a little picture here, this isn't terribly helpful because you'll notice this is not a right triangle. However, if I was to, it is, however, it's symmetric. This part over here matches this part over here. So if I drew this line of symmetry here, then that would be a 90-degree angle, and it looks like this part right here would just be half of this 62-degree 20-minute angle. This part right here would end up being, well, 31 degrees and 10 minutes. Alright, well that also means that this 5.500, it looks like that depth is exactly this distance right here. I don't really need the rest of this stuff right there. I'll just kind of erase that and make this into a right triangle like I have here. I'm trying to find the width. Actually, let me put the dotted lines on here to show where that is. Alright, so if I'm trying to find the width of this V-slot, that means I want this distance, because I'll double that and that'll give me the full width. So let's call this, I don't know, X. Okay, so what I have here is I have one of the side lengths of this triangle. It is a right triangle, and I have one of the angles, which means I'm going to use one of the trigonometric ratios here. So let me write SOHCAHTOA. And if this is my reference angle, then I have, this is my opposite side, and this is my adjacent side, adjacent leg. So that means the two angles, the two sides I'm talking about, are the ones that are described in the tangent. So that means the tangent of 31 degrees and 10 minutes, so 31 degrees and 31 plus 10/60ths of a degree, I should say. The tangent should be the opposite over the adjacent. Something like this. The tangent of this angle should be the opposite, which is our unknown, divided by the adjacent. Alright, well, I can solve that easily enough. Multiply both sides by 5.5, I get 5.5 times the tangent of my angle. And that's something I can just plug into the calculator. This is 5.5 times tangent, parentheses 31 plus 10/60ths, gives me this number, 3.3265. Now, of course, this was only half of the width of my groove that I'm creating, so the groove, W, must be 2 this, 2 times X. So I'll take this number times 2. And if I want this rounded off to the nearest thousandth of a centimeter, that means I'm probably going to want this to the nearest thousandth of a centimeter as well. That's a good guideline for where to round on this particular instance, to 4 significant digits. So I'll go 6.653 centimeters.